All right, guys. So now we're going to talk about inverse functions. Inverse functions. So when we define an inverse function, we're talking about, first off, let's talk about relations before we talk about functions. Note that a relation, right, is the pairing of input values to output values. Now we say input, output, but we realize that's like X, right, and Y. So when we speak of inverse relations, inverse relations interchanges the input and output values. Okay, it interchanges the input and output values. So let's say we have the following table as a relation, and we know it's a relation because there's the pairing of input to output, input, output, right? So that's how we know this is a relation. And so this is our example of relation. I'm going to go ahead and label it, right? And then how would we write a table for our inverse relation? We would simply switch the X and Y. So now we have 8, -1, 6, 0, 4, 1, and then 2, 2, and then 0, 3. And so now this is an example of an inverse relation. Period. All right. So there's more I could say here, but let's go on to functions, okay? Let's go on to functions. So when we're dealing with functions, right, we call it f and g. We know that f and g are inverses of each other. Provided that when we compose, so composition is what we talked about yesterday in class, right? So when we talk about inverses, when we compose f with g of x, I like to put g of x like this. Think of it as g of x is the new domain, right, of the function f. When we compose this and we get x, and when we have our g of f of x, I did something wrong here. Okay. Trying to get colors right, guys. All right. Great. So when we compose g of f of x with an f of g of x, then what we're expecting to get out each time is the value, not value, but the variable x. Okay. And so when that happens, we can say f and g of x are inverses. So then the function g is denoted f inverse. Well, we say f, but this is read as f inverse. Hopefully that makes some sense, okay? It's read f inverse. So that's how we determine whether two functions are inverses. We're going to use this composition, which you learned in class yesterday, okay? And they both have to be equal to x. If not, then they're not inverses. So let's say, for example, we want to verify here that f of x is equal to 3x minus 5 and g of x is equal to 1/3 x plus 5 over 3, and we want to verify that they are inverses. Then the first step that we're going to take here is we are going to compose f of g of x. We're going to compose g of x with the f of x. But we want to verify, hey, is this equal to x? ? question mark. And then the second thing we're going to do is do the other way around, right? We have g of f of x. And we want to see, hey, is this going to be equal to x? So I like to use colors because it just helps to kind of differentiate things. So let's say our f of x is pink. Our g of x is pink, while our f of x here is going to be green. Okay. So what's going to happen here is we're going to put g of x inside of f of x, right? Remember, g of x is the 1 over 3x plus 5 over 3. And so we have 3, parentheses, minus 5. But inside of here, we're just writing the 1 over 3x plus 5 over 3. And hopefully you know about multiplying here. That 3 times a third x would just give us x. And 3 times 5 over 3 would just give us 5. Then subtract 5. Okay, we know 5 minus 5, that's 0. So we are left with x here. Right on. One of them checks, right? Now we have to check the other. So remember that this one, we're going to put in green. That's 3x minus 5, right? And so the way we're going to write this one is we have 1 over 3, parentheses, plus 5 over 3. And what we're going to put here inside is 3x minus 5. So we're going to distribute the 1/3. 1/3 times 3x is just x. 1/3 times the negative 5 is minus 5 over 3. Plus 5 over 3. This is doing what we needed to do as well. And what we're left with is just x. So what does this mean? This means that our f of x and g of x are inverses. So now we can write that g of x is actually now f inverse of x. What I mean is we can say that our f inverse of x is 1 over 3x plus 5 over 3. Now that we've shown f of x and g of x are inverses. So here it is. And we would just write they are inverses. So f of x and g of x are inverses. That's it. Now with our next example, it's asking us not to verify, but to find the inverse of f of x equals x squared when x is greater than or equal to 0. And then it wants us to graph our f of x and f inverse of x. So the steps to this are as follows. I've already written them out. Feel free to, of course, pause and write and do whatever you need to do here. So the first step is we need to change from f of x to y. And then we're going to switch our x and y, and we're going to solve for y. And then we will replace the y with f inverse of x. This is how we find the inverse of functions. So let's get started. Remember, our first step is we're going to change f of x to y. So now we have y is equal to x squared, right? First step. Second step, we're going to switch x and y. So now we have x is equal to y squared. Third step is we're going to solve for y. So basically, we're saying we want to get this y by itself, so we need to get rid of the square. The only way to get rid of square is by taking the square root, right? Because they're inverse operations. So this would be the square root of x is equal to y squared, the square root of y squared. And so the squares cancel. So we're left with y equals the square root of x. All right, y equals the square root of x. And I'm sorry, we took the square root, so that's actually plus or minus. So when we take it, this is plus or minus. Or we just say y is equal to plus or minus the square root of x. Remember that this is the third step, but our final step is to replace y with f inverse of x. So f inverse of x is equal to plus or minus the square root of x. Okay, so from here, what we're going to do, we want to graph it, right? So first off, let's talk about our xy table, where y is x squared, right? So we're going to do simply -2, -1, 0, 1, 2. And then for x, we're substituting each of these values. So it would be -2 squared, -1 squared, 0 squared, 1 squared, and then 2 squared. So that comes out 4. That comes out 1, 0, 1, 4, right? And then let's do the other. So it did say it wanted x to be greater than. I do apologize. But it's okay. It'll be okay. We don't have to worry too much. All right, so let's say then we know we have x and y is equal to the square root of x, but we also have x and y is equal to negative square root of x, right? So this is the part that really matters. We don't need to look at -2 or -1 because we can't take the square root of a negative without it being imaginary. We don't want to deal with that. So what we are going to look at is, we're going to start with 0. Then we'll go to 1. We can do 2, and then we'll do 4, okay? So the square root of 0 is 0. Square root of 1 is 1. Square root of 2 is 1.4, and the square root of 4 is 2. We're going to do the same thing for the negative square root of x. So that's 0, 1, actually -1, and then -1.4, and -2, like that. So let's look at what this graph is going to be. Let's see if I got, nope, I need to make the graph. So, which is fine. So let's say 2, 3, 4, 5. All right, so what we're going to do here is we're going to start off by graphing x squared. This is going to be our first. So -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. All right, I'm going to do that in pink. Okay, so this is our y equals x squared. All right, and I'm going to do, now, y is equal to the square root of x. So this will be, we'll start at 0, 0, then 1, 1, then 2 and 1.4, and then 4, 2. 3 is technically 9, so it's kind of off. So we're not going to go there. But notice, what do we see, right? That's the first part. Now we have to graph this one, right? The y equals negative square root of x. So that's going to be the 0, 0, 1, negative 1, 2, negative 1.4, and 4, negative 2. So we start at 0, 0, right? And then we have 1, negative 1. Then we have 2, negative 1.4. And then we have 4, negative 2. That kind of went off a little. So, be something like that. And then here we are, right? This is our f inverse of x, the square root of x, okay? So what we want to note is the reason we have to compose f with f inverse of x is because, and get x. Notice that if we were to fold this right along x, I don't think I'm going to do the perfect job here, but I am going to try my best to show you. When you fold along this line, these will reflect on top of each other. All right. Now, an important thing to know is this horizontal line test. Whenever you want to test whether, well, let me just say what it says. The inverse of a function, f, is also a function if and only if no horizontal line intersects the graph of f more than once. And that should say the graph of, okay, got it. Yeah, the f, it's meant to be f. So we can tell whether the inverse is a function by looking at f. Notice that this is a parabola, right? Right here, the pink. It's a parabola. However, we know that the inverse is not a function because if we take a line, any line, let's say right here, notice how the graph crosses the horizontal line twice. And what that means is that the inverse is not going to be a function. And it's proven right here, look, by the vertical line test. Because this graph of the inverse of x squared crosses twice. But we know that because of the horizontal line test on the original f of x. Just a little known fact. That is the horizontal line test. All right, I am now going to end the video.